Hello, this is John from caveofprogramming.com, and this is tutorial number 8 in our series of advanced Java multi-threading tutorials from Cave of Programming. And this tutorial is actually on wait and notify. Now, in the last tutorial we took a look at implementing the producer consumer pattern in Java using array blocking queue. And in this tutorial I was going to show you how to do that using low-level thread synchronization techniques, just in case you need to know these techniques. But what I'm actually going to do is I'm going to look at the producer consumer pattern again in the next tutorial, and in this tutorial I'm just going to show you basic usage of wait and notify to break things down a bit. So I've got a main application set up here which looks quite ferocious, but all it's actually doing is it creates a new processor object, which is this class here that just has two methods called produce and consume, and it runs those two methods in two different threads, and it just waits for those threads to finish. So produce is running in one thread and consume is running in another thread, and I've called them produce and consume because in the next tutorial we will look at this in the context of the producer consumer pattern. But for now, these are just basically these two methods are just running in different threads, and that's the important thing. So what I'm going to do here is I am going to firstly put a thread.sleep in this thread, so that I'll just say 2 seconds, so that I know that this thread will get a chance to kick off first. And I'm going to have a synchronized code block in here, synchronized, and I need an object to synchronize on, so I'll synchronize on the processor object itself, because I could use any object, but I'll use the intrinsic lock of processor. So this can't run until it's acquired the intrinsic lock of the processor object. And in here I'll say sysout producer thread running, and then I'm going to call wait. And what wait is every object in Java has a wait method, because it's a method of the object class that is the ancestor of all objects in Java. And actually there's two sorts of wait. There's a wait like this, and there's also a wait that lets you specify a timeout, which is probably the one that you usually want to use, because this could cause your thread to wait indefinitely if you're not careful. But anyway, so what wait does is it waits in such a way that it doesn't consume loads of system resources. So if you have, for example, a while loop that keeps checking a flag with nothing in the loop, that's a tight loop like that will use a lot of resources in your system. But wait doesn't. It's very resource efficient, and it actually, you can only call it within synchronized code blocks. That's very important, and it actually hands over control of the lock that the synchronized block is locked on. So at this point, this synchronized block will lose control of the lock, and this thread will not resume until two things happen. One thing is that it must be possible for this thread to regain control of this lock in order for this to resume. And the other thing is I must, from another thread that's locked on the same object, call a method called notify. So here, just to see what's happening, I'll put a sysout resumed. Now here I'm going to have another synchronized code block, and this is very important. I will lock this on the same object, so I'm using the same intrinsic lock for both of these, the same lock for both of these sections, synchronized sections of code. And so this is going to run first because I've put this sleep in here, and then when this gets to wait, it will hand over control and relinquish that lock, and then this will be able to run and acquire the lock. And in here what I'm going to do is I'll have a scanner object here just to get user input scanner system.in. This is a really handy class for getting console input. And I will say here, first I'll do a sysout. I'll say waiting for return key, and I'll call scanner.next line, which will wait until I press the return key. So this runs, then it hands over control of the lock and it waits, and then this will run after this sleep is finished, and then it will pause just because it will wait for me to hit the return key, so it will wait at that point. And when I hit the return key, I'm going to call notify, and then I'm going to do sysout return key pressed. In fact, really I should put that before my notify, I think. So I'll put that here, and then as soon as I hit the return key, I'll call notify. Now there's two sorts of notify, and again, notify can only be called within a synchronized code block. And notify here will notify one other thread, and it's the other thread that the first other thread to lock on this same lock object. It will notify that thread that if it's waiting, it can wake up. But it doesn't, notify does not relinquish control of this lock. So after you call notify, you will usually want to relinquish control of the lock very quickly, because otherwise this will not resume, because it will not be able to get the lock again. And there's also a notify all, which notifies all threads that are waiting on this same lock. But here I've just got one other thread, so I'll just use notify, which is more efficient if you just have one other thread that has called wait. So let's see what that does. I'll run that, and it says produce a thread running, and then we get to wait here immediately after this is output, and then this hands over control. It relinquishes this lock, and then here in this other method, in this other thread, in fact, sleep finishes, and then this is able to get control of the lock because this has handed it over with wait, and this says waiting for return key, and it waits for a return key, and at that point everything's halted. So this is waiting for a return key, and this won't carry on until notify runs. Now I'll hit the return key, and you see here this outputs return key pressed. It calls notify, and as soon as notify is called, it exits the synchronized block, and this wait returns, and this reacquires the lock, and then it says resumed. So this is a very handy mechanism for synchronizing the behavior of your threads, and we will look at this. In the next tutorial we'll look at how to produce a consumer using this technique. Now, just to prove the point that notify does not hand over control of the lock, unlike wait, I'm going to just put a thread.sleep in here. Thread.sleep, let's say 5 seconds, 5,000 milliseconds. Now if I run this, what we'll see is this thread will not resume until I press the return key and this sleep has finished, because calling notify is one thing that will tell this to wake up, but this won't actually get past, it won't actually carry on until it can reacquire the lock, and it can't reacquire the lock until this block has relinquished the lock and my thread.sleep has finished. So I'll run that, produce a thread running, this sleep expires, it waits for the return key. Now I'll hit the return key, and we're waiting now 5 seconds, this is running, and finally after 5 seconds this relinquishes the lock, and then this can finally continue, and we get resume being output. That's all for this tutorial. In the next tutorial I'll show you how to produce a consumer with this, and you can find this code on caveofprogramming.com, that's all one word. So do take a look at that, and do join me again next time, and until then, happy coding.